Welcome. This video serves as the Part 4 tutorial for VISSIM presented by Kapwali Pomona. From the last video, you learned how to change vehicle parameters to project the network's vehicle composition and speed distribution. You also learned how to define the time intervals for the vehicle volume. In this video, you will learn how to input vehicle data from PEMS and how to assign vehicle routes. I will also cover how to add data collection points on your network and how to start your simulation. Vehicle volume data can be found on the Excel spreadsheet your professor has provided for you. VISSIM enables its users to input the time-dependent traffic demand data and adjust for realistic vehicular behavior. The key metric for vehicle input is volume or the number of vehicles in a given time frame. To input the time-dependent traffic demand data, locate the entrance of your desired link. This is where the vehicles will start their journey on the network. Select Vehicle Inputs under Network Objects. Right-click on the link and select Add New Vehicle Input. A black line will appear across all lanes at the beginning of the link. Double-click on the black line. The Vehicle Inputs window will appear below the network editor. From the drop-down list, select Vehicle Volumes by time interval, and the window will split into two sections. Open the Excel spreadsheet that contains the 5-minute loop data from the PEMS website. Make sure that the 5-minute volumes from the Excel spreadsheet have been converted to per hour by multiplying the entire total flow column by 12. Excel allows columns to be filtered by a specific criteria. Under Data, select Filter and a small down arrow will appear next to every column header. This option might help you quickly find the appropriate station ID. Locate the appropriate timestamp and station ID. For this tutorial, I will be using station 772903, which is a mainline. I will be using the traffic volume from 6 o'clock a.m. to 9 o'clock a.m. Do not include the volume for 9 o'clock as that will be the volume for 9 o'clock to 9:05 a.m. Select the 36 cells under the hour flow column. Press Ctrl+C on your keyboard to copy the exact number of vehicle volume intervals or cells. There has to be 36 of them. Then go to a new sheet to copy and transpose the volume. Select and copy the 36 transposed hour volume and then go back to VISSIM. In the left section of the Vehicle Inputs window, press Ctrl+V to paste the volumes from Excel. Vehicle data can be assigned a stochastic value or exact values. For accurate GEH values, use the exact volume type. Change the volume type for all rows to exact. Repeat previous steps for every unique entry point, such as on-ramps in your network. To assign vehicle routes, click on the Vehicle Routes under Network Objects. Locate the entrance of your desired link. This is where the vehicles will start their journey on the network. Right-click on the link and select Add New Static Vehicle Routing Decision. A pink line will appear across all lanes and a blue-teal line will follow your cursor. The yellow path connecting the pink and teal lines is the vehicle route. Move your cursor along the highway until you reach the very end of the first off-ramp. Left-click on the off-ramp to define your first vehicle route. Move your cursor on the main line somewhere slightly past the first off-ramp. Left-click on the main line to define your second vehicle route. Double-click anywhere off the highway network links to finalize your choices. Double-click on the pink line of your vehicle route. The Static Vehicle Routes window will appear below the network editor. Select the Static Vehicle Routing Decision from the drop-down list and the network editor will split into two sections. In the left section, click on the first row or the row with the off-ramp as the destination link. Locate the appropriate timestamp and station ID of the first off-ramp. I will now be using station 761228, which is an off-ramp. Select the 36 cells under the hour flow column for the off-ramp. Transpose the data to appear horizontal. Press Ctrl+C on your keyboard to copy the total vehicle counts. In VISSIM, locate the relative flow 0 cell for the off-ramp in the left section of the Static Vehicle Routes window. Press Ctrl+V to paste the volumes from Excel. In the left section below the network editor, click on the second row or the row with the mainline as the destination link. Locate the appropriate timestamp and station ID of the mainline. I will now be using station 765486. Select the 36 cells under the hour flow column for the mainline. Transpose the data to appear horizontal. Press Ctrl+C to copy the total volume counts. In VISSIM, locate the relative flow cell for the mainline in the left section of the static vehicle routes window. Press Ctrl+V to paste the volumes from Excel. Repeat previous steps if your highway network has multiple off-ramps. Loop detectors or stations are added in VISSIM to collect data such as vehicle counts and speed. Before adding data collection points in VISSIM, Google Maps can be used to locate each station's approximate location. Locate every loop detector using Google Maps Street View. Mainline loops are often upstream and downstream from off-ramps and on-ramps. In VISSIM, select Data Collection Points under Network Objects. Move the cursor over the exact location and lane. Right-click and select Add New Data Collection Point. Once placed, the collection points can be moved by dragging them around with your mouse. They can also be deleted by selecting each or multiple collection points and pressing Delete. Add every data collection point for every lane at each loop detector location for your entire network. Double-click any collection point to make a window appear below the network editor called Data Collection Point. Name every collection point with its corresponding station ID. On the top toolbar, select List, and then Measurement, and then Data Collection Measurements. A new window will appear below the network editor called Data Collection Measurements. In an empty area of the new window, right-click and select Generate All Grouped. From the top toolbar, select Evaluation and then Configuration. In the new Evaluation Configuration window, select the Result Management tab. Select Of All Simulation Runs, uncheck the Automatically Add New Column list, select File, and then select the Result Attributes tab. Check the box for data collections under the Collect Data column. Change from time to 0, to time to 10,800, interval to 300. From the top toolbar, select Simulation and then Parameters. In the new Simulation Parameters window, change the period to 10,800 and then click OK. Select the Data Collection Measurements tab below the network editor. Click the Select Attributes button, that is the black wrench. In top left corner of the new window, click the Filter button. In the new Pre-Selection Filter window, under Simulation Runs, select Show Only Selected Simulation Runs, and then check Current Run. Under Interval Times, select Show Only Selected Time Intervals, and then check Last Completed, Total, Average, and all time intervals from 0 to 300 to 10,500 to 10,800. Back in the Data Collection Measurement Select Attributes window, click on the Vehicles attribute. Click on the green arrow to add every vehicle attribute for all time intervals to the right-hand section of the window, and then click OK. Now, in the Data Collection tab below the Network Editor, each collection point group will have their own time interval as a column. Do not forget to save your file. It is always a good practice to save your file under a different file name to keep track of the changes you have made. Before running a simulation, assure that each previous section has been implemented. The following section is the most basic method of extracting simulation data from VISSIM. Identify where the simulation data will be saved by selecting Evaluation, Configuration from the top toolbar. Click the ... button and select the location or folder as your desired output directory, and then click OK. Set the simulation parameters by selecting Simulation and then Parameters from the top toolbar. Change period to 10,800 for 3 hours. Simulation resolution to 10. Random seed to any number you want. Change the random seed number to avoid similar results. Number of runs to 1. Simulation speed to maximum. Number of cores, use all cores. Select the Data Collection Measurement tab below the Network Editor. Click the Autosave After Simulation button. On the top toolbar, select Simulation and then Continuous. Now sit back and watch the simulation run. While the simulation is running, make a note of the following vehicular characteristics. Vehicles are entering and exiting through the appropriate locations. HGV are generated by the simulation. Look for unusual behavior such as stuck vehicles, merging issues, disappearing vehicles, unused lanes, connector issues, and more. Watch the entire simulation carefully, zooming in and zooming out to locate trouble areas. Let the entire simulation finish to automatically save the results. Values will begin to generate in the Data Collection Measurement window as the simulation runs. Again, do not forget to save your file before exiting. Thank you for watching. Be sure to watch the next video to learn about the GEH formula.